I think it's hard to separate my hope from my objective intuition about what superintelligent systems look like.
If one studies evolutionary biology with a bit of math, and in particular, like books from when the field was just sort of like properly coalescing and knowing itself, like not the modern textbooks, which are just like memorize this legible math so you can do well on these tests, but like what people were writing as the basic paradigms of the field were being fought out.
Yeah.
In particular, like a nice book, if you've got the time to read it, is Adaptation and Natural Selection, which is one of the founding books. You can find people being optimistic about what the utterly alien optimization process of natural selection will produce in the way of how it optimizes its objectives. You got people arguing that, like, in the early days, biologists said, well, like, organisms will restrain their own reproduction when resources are scarce so as not to overfeed the system. And this is not how natural selection works. It's about whose genes are relatively more prevalent in the next generation. And if you restrain reproduction, those genes get less frequent in the next generation compared to your conspecifics. And natural selection doesn't do that. In fact, predators overrun prey populations all the time and have crashes. That's just like a thing that happens. And many years later, but people said, like, well, but group selection, right? What about groups of organisms? And basically, the math of group selection almost never works out in practice is the answer there. But also, years later, somebody actually ran the experiment where they took populations of insects and selected the whole populations to have lower sizes. Like you just take pop 1, pop 2, pop 3, pop 4, look at which has the lowest total number of them in the next generation and select that one. What do you suppose happens when you select populations of insects like that? Well, what happens is not that the individuals in the population evolve to restrain their breeding, but that they evolve to kill the offspring of other organisms, especially the girls. So people imagined this lovely, beautiful, harmonious output of natural selection, which is these populations restraining their own breeding so that groups of them would stay in harmony with the resources available. And mostly the math never works out for that. But if you actually apply the weird, strange conditions to get group selection that beats individual selection, what you get is female infanticide. Like if you're like reading on restrained populations. And so that's like the sort of, so this is not a smart optimization process. Natural selection is like so incredibly stupid and simple that we can actually quantify how stupid it is if you like read the textbooks with the math. Nonetheless, this is the sort of basic thing of, you look at this alien optimization process and there's the thing that you hope it will produce, and you have to learn to clear that out of your mind and just think about the underlying dynamics and where it finds the maximum from its standpoint that it's looking for, rather than how it finds that thing that leapt into your mind as the beautiful aesthetic solution that you hope it finds. And this is something that has been fought out historically as the field of biology was coming to terms with evolutionary biology. And you can like look at them fighting it out as they get to terms with this very alien inhuman optimization process. And indeed, something smarter than us would be also be much like smarter than natural selection. So it doesn't just like automatically carry over. But there's a lesson there. There's a warning.
So to you, natural selection is a deeply suboptimal process that could be significantly improved on and would be by an AGI system.
Well, it's kind of stupid. It like has to like run hundreds of generations to notice that something is working. It doesn't be like, oh, well, I tried this in like one organism, I saw it worked. Now I'm going to like duplicate that feature onto everything immediately. It has to like run for hundreds of generations for a new mutation to rise to fixation.
I wonder if there's a case to be made that natural selection, as inefficient as it looks, is actually quite powerful. Like that this is extremely robust.
It runs for a long time and eventually manages to optimize things. It's weaker than gradient descent because gradient descent also uses information about the derivative.
Yeah. Evolution seems to be, there's not really an objective function.
There's inclusive genetic fitness, is the implicit loss function of evolution,
It's
which it
implicit.
cannot change. The loss function doesn't change, the environment changes, and therefore like what gets optimized for in the organism changes. It's like take like GPT-3. There's like, you can imagine like different versions of GPT-3 where they're all trying to predict the next word, but they're being run on different data sets of text. And that's like natural selection, always inclusive genetic fitness, but like different environmental problems.
It's difficult to think about. So if we're saying that natural selection is stupid, if we're saying that humans are stupid, it's hard.
Smarter than natural selection,
Smarter.
stupider than the upper bound.
Do you think there's an upper bound, by the way? That's another hopeful place.
I mean, if you put enough matter, energy, compute into one place, it will collapse into a black hole. And there's only so much computation can do before you run out of negentropy and the universe dies. So there's an upper bound, but it's very, very, very far up above here. Like a supernova is only finitely hot. It's not infinitely hot, but it's really, 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 really hot.